I'm sorry, I know you listed this, but where is it again?
It's okay. It's under spring final review, the student notes resources. If you look at, or if you could download final review part 2. We're going to finish up chapter 4 and 5 and 6 today, kind of review the rules that we need to remember from the semester. And then after this, you guys will have time to finish the first review and then to work on preparing for the final. Then again, just like the first review was performed, the bolded questions, these are ones that you guys can choose to get extra practice over that type of problem from your book. In the same way that the answers were posted for the part 1 review, the answers will be posted for part 2. So you'll just have to kind of look and see what page they refer to and check your answer as you go. And I'm missing my surface points. I'm wondering if I just left it here last night. Okay. All right, guys, are we ready to get started? Okay, number 1, write 4 squared equals 16 in logarithmic form. And just so you guys know, I'm going to give some Road to Excellence for answers today. I do have donuts to give away for Road to Excellence today, so I'll pick those as soon as we're finished. So raise your hand if you can remember. How do we write 4 squared equals 16 in logarithmic form? Jack.
Log base 216 equals 4.
Close. Charlie.
Log base 4, 16 equals 2.
Nice. We do want to be careful that the base is the one that's holding up the subscript. And so the base of the exponential becomes the base of the log. One of the things that we learned back in chapter 4 is that if you have log base anything of x is equal to b, this is interchangeable with the statement a raised to the b power is equal to x. All right, on to number 2. Number 2, ln of 1 equals, can you raise your hand and tell me what is ln the same as? Oh, you guys all got it. Nice. Log base e. So if I'm asking log base e of 1 equals what? Well, then I can just transfer this back to exponential form, and I would ask e raised to what power has to equal 1? 0. Nice. So the answer is 0. Very good. Number 3, log base 2 of 4 to the 1/3. Does anybody remember how to evaluate this one? I mean, you technically could do that. You could. Okay, so if I change this guy to the same base as this guy, then it would be log base 2 of 2 squared raised to the 1/3. Nice. One of the rules I want to remind you guys of is that if you have log base a of a to the x power, it does equal just x. So if we can just kind of match this, then we can figure out what the value is. What happens when you raise an exponent to an exponent? What do? Multiply. Awesome. So this is actually the same as log base 2 of 2 raised to the 2/3. Turn to your partner and see if you can answer what would be the answer then to this law. Okay, for Road to Excellence for you and your partner, raise your hand if you can tell me what would be the answer. Caden. Nice. The answer is 2/3. And we can write that.
What does it say, yellow? Next to 2?
2 over 1.
Oh.
I just changed it to 2 over 1 times 1 over 3 to make sure that we could have 2 raised to the 2/3. But then, yes, the answer would be 2/3. On to number 4. ln of e equals x, written in exponential form, is, well, quicker. Actually, Chloe, go ahead and let.
E to the x equals b.
Awesome. How did you figure that out?
Because you take like the smaller number, like log to the base, you take the base, and that's the number, and it's raised to what it equals, which is x.
Nice. So you knew that ln was a log base e, right? And then you said the base would have to be e, and then you said e raised to the x power equals e. Perfect. Nice job, Chloe. If I asked you to solve that, what would be the answer for x? 1, exactly. E to the first is equal to e. Okay, number 5. Which of the following does not have x equals 0 as a solution? Circle all that do not have x equals 0 as the solution. How about letter A? If I plug in x as 0, does it make sense that 2 to the 0 minus 1 would equal 0? Yeah, because 2 to the 0 is 1. 1 minus 1 is 0. Letter B, does it make sense that e to the 0 is equal to 1? Yeah, okay, so obviously that's going to be letter C, but let's make sure we know why. What can we not take a log of? 0. Or what else can't we take a log of? Negative. Awesome. So you can't take a log of 0 or a log of a negative. If you forgot that, I'd maybe write it as a side of something to study. So this one would be C. And I'll just go ahead and write it here. We cannot take a log of 0 or of a negative. Nice. Okay. Use the properties of logs to expand the following logarithm. It might be helpful to review the properties of logs, and then we can go ahead and practice working with them a little bit. One rule that we looked at was called the product property, and it said that if you have log base A of B plus log base A of C, it's equal to, raise your hand if you know. Elijah.
Log base A of B times C.
Nice. Log base A of B times C. Nice job, Elijah. For the next one, we saw in a property that if you have log base A of B minus log base A of C, does anybody remember the property? Charlie.
Log base A of B divided by C.
Nice. Log base A of B divided by C. Nice job, Charlie. And there was one last property that said if you had, for example, C times log base A of B, it was equivalent to what? Cayman.
Log base A of B to the power of C.
Nice. Okay, if you remembered those, great. You don't have to study them. If you're like, you know what, I'm a little rocky on those, maybe write it on a note card, study those because they will show up on the final. And let's take a look at number 6 and see how can we use those to expand the log out. So I could just kind of move through this one step at a time or do it all in one. But this division symbol, I know it's going to separate the logs using subtraction. So I would have log base 2 of 2 times x minus log base 2 of 3. And then how am I going to separate the 2 times x? Addition. Nice. So this will become log base 2 of 2 plus log base 2 of x minus log base 2 of 3. And I would say this is great, but since the test is multiple choice, what if you don't see this answer, but instead you see this? Can you recognize why this is actually the same? Excellent. Log base 2 of 2 is equal to 1. So you just want to kind of be thinking, hey, what are some equivalent values? But both of those would be correct. All right, number 7. So what's the other properties? The third one, C times log base A of B equals log base A of B to the C power. It's the power property. All right, we've warmed up our work with properties for a little bit. So why don't you turn with your partner, number 7, and try this one. How about the person with the darkest colored shirt in the group? You share what you would do first.
This is process.
Yeah. I think yours is darker.
Alright, so log base A is square root of x plus log base A y minus log base A
You separate the x and y, raise it to log x plus log ax squared.
no states of x
No root.
because they're separated
No,
by
it's just Oh, I see.
they're
And then
separated
it's
by
minus the log
subtraction, so you can do it.
y squared minus 1 because you can't separate it with subtraction.
Well, minus log A, y,
You can't take a log.
divided by log y is like one. Or is it
Right.
like one?
It's one thing because you can't separate it from fraction. Or,
Oh.
No, but it's.
Yes, but it's just,
Yeah,
it's
yeah,
not,
so
yeah,
when
no,
you-
yeah.
I got 1/2 log X.
Normally,
Log
yeah.
A Y can be divided by or minus parentheses log A Y plus one minus log C. Why would it be one X?
Because I did. Okay, and then you have
Oh,
to,
wait, but then.
not for this, that's wrong. I think you have to take the power properties, you have to make the max 1/2.
Why would you?
So 1/2 log,
Well,
instead of
then you could go log A times square root of X minus
plus log,
to the y minus log A to the y minus 1 plus.
And then minus.
All right, ladies and gentlemen, this is an answer, but it's not the fully correct answer. Raise your hand if you can tell me, how would I be able to expand this log further? Well,
It would be 1/2 log A to the X plus log A to the 4 minus 2 log A to the 1 minus 1.
so I do have to be careful. These two are connected with a -1, so I can't actually separate that 2 yet, but it's always a good thing to look for. There's something else actually I'm looking for here. Abby? Ah, y squared minus 1 is really y minus 1, y plus 1. True. Then what could I do? And I'd have a plus sign, right?
Yeah.
Because they're product property. Awesome. Yes. If you can factor a binomial or trinomial, you always do so in a logarithm so that you can separate it using the product property. Nice job. Now, one thing to also be aware of is I do have the minus sign pulled out in front of the parentheses. I could have also had this as 1/2 log base A of X plus log base A of Y minus log base A of Y minus 1 minus log base A of Y plus 1. Either of those are good. What you can't do is remove those parentheses because then you'll miss the distributive property. Oops, somebody's there. All right, let's take a look at solving exponential or logarithm equations. So solve each of the equations for the unknown, show all your work, circle your answer involving logs, and round it to the 4 decimal places. You don't quite know how the multiple choice question will be given, either as logs or in decimal format. So we want to make sure that we know how to do both. Number 3, could someone raise their hand and tell me what would be the first step in solving this? Lainey. Nice, take an ln of both sides. So I'm going to take an ln. Oops, I'm going to choose a smaller pen because this should have probably given us a little bit more space. Then what do we do, guys? Good, bring the x plus 1 out in front using the power property and the x minus 1 out in front. So I have x plus 1 times ln of 10 equals quantity x minus 1 times ln of 2. What am I going to do with that ln of 10? Chloe?
You want to separate it, the x plus 1, so it's x on 10.
Nice. I need to get rid of those parentheses, so I need to distribute. And that gives me x times ln of 10 plus 1 times ln of 10 equals, I want to do the same thing on the other side, x times ln of 2 minus ln of 2. I see x on this side and this side of the equation. So what am I going to do? Get them on the same side. Good. So I'm going to subtract. Make this a little bit of a smaller pen so I can write that. I'm going to subtract x natural log of 10 over here. And I'm going to add natural log of 2 over here. So I can start moving the x's together. So I have natural log of 10 plus natural log of 2 is equal to x natural log of 2 minus x natural log of 10. Now I have the x's on the same side of the equation, which is beautiful. So what can I do with it? I could, okay, so Laney's noticing that I could call this side natural log of 20. If I wanted to, that'd be great. What can I do with the right side? Take the x out. Good, let's factor that out. So if I factor it, I would have x times quantity natural log of 2 minus natural log of 10. And then what's the last step that I'll do? Divide everything by what's been multiplied by x. And this would be my answer for x in log form, or I could technically use properties to make it different. But let's make sure we know how to do this in decimal form as well. So I would press alpha y equals n over d, and I'm going to choose natural log of 10, close that, plus natural log of 2, close that, over natural log of 2, minus natural log of 10, close that, and my answer to 4 decimal places would be negative 1.8614. Negative 1.8614. Lily.
So I know that you can't like separate the ln2 and ln10 because they're quantities, but if you rewrote it as ln2 plus ln10,
That's fine.
and then would that be able to cancel it because addition and subtraction are the same numbers?
You couldn't cancel it because these are terms, not factors.
Okay,
So
so
we-
the quantity doesn't still. or
Yeah,
the-
still stays as one quantity. Elijah.
So if you asked for it in log 4, would you want that, or should we simplify it to like column 20?
I'll just give you guys how it's going to look. I'm going to ask for it in decimal form. So just make sure you know how to use that decimal. How could we check this to see, hey, did I get it right? That was a lot of steps.
But then
Plug that in for x. And just as a quick reminder, I would do 10 raised to the, I want that exact answer. So do you guys remember how to select that exact answer?
Or
Yeah, second negative is your answer if you want that. So I could say, what is 10 raised to that answer plus 1? And that would be 0.1376. And I want to make sure that that's the same as 2 raised to the, if I want that answer back, I can just actually scroll up and say, hey, take that logarithm answer and subtract 1 from it. And that answer is equivalent to both sides of the equation, 0.1376, 0.1376. So I know, great, I did that work right. All right, on to number 8. Number 8, what would be a first step that we could do to solve? Take the natural log of both sides, awesome. And then we'll bring that power property again out in front. So I'd have 2 minus 2x times the natural log of e is equal to natural log of 10. Question for you. What is natural log of e equivalent to? 1. Awesome. So I can just say this is 1. I don't need to distribute it. You could. But natural log of e is equivalent to log base e of e, which is 1. So I really just have 2 minus 2x equals natural log of 10. And now I can just go ahead and start getting x by itself. So I'm going to subtract 2 to both sides. Smaller. And I have negative 2 times x equals natural log of 10 minus 2. And then I can just divide everything by negative 2. And now in my calculator, I'm going to type this in. Do not combine the 10 minus 2. Natural log of 10 is considered 1 decimal value. I don't want to call that natural log of 8, or I've changed that value that it will be. So I'm going to go ahead and type in alpha y equals, what is natural log of 10, close that parentheses, minus 2 divided by negative 2. And my answer is negative 0.1513. negative 1 point, what did I just say? 1513. 1513. And that would be my answer. Could I check this? Yeah, I'd plug it back in for x in the same way that we did and see does it equal 10. Actually, speaking of, because it's been a while since we've done this on the calculator, do you guys remember how to access e raised to a power?
Second LN.
Good, second ln. If I want e raised to that, I've already forgotten it, 2 minus 2 times x. I could say, what's e raised to the 2 minus 2 times that answer? Second negative, please be 10. It's 10, so I got it right.
How do you do log of any base?
Log of any base, that's a good one to remember. If we press alpha window, option number 5 allows us to do log of any base. So you guys get your calculator on the entire test. Those first few that we walked through, you could check yourself. Okay, am I thinking through this right?
What's, sorry,
What?
what's log?
Alpha window,
Okay.
option number 5.
We now alpha window. Let's see that.
We do. We use a lot of those, the alpha up there. All right, number 9. First, oh, Chloe.
So you got negative 1.1.
Negative, oh, no, I wrote it down wrong because it's hard for me to, thank you. It should be negative 0.1513. Thank you, Chloe. Okay, number 9. There is no base of these logs. What? What's that understood to be? 10. Good. So write 10 and 10 in. You don't have to if you knew it, but it's important to know. Now, when you have a log equation, the goal is to isolate the log so that you can convert it to exponent form. Right now I have 2 logs. How can I make just a single one? Combine them. What property would combine them? Multiplication. Awesome. So we're going to have log base 10 of w times 3w minus 13 is equal to 1. Remember, if you're ever stuck in log form, change it to exponent form. So keeping that in mind, what would be the base of my exponent form? 10. Good. What would I raise it to? 1 equals w times 3w minus 13. Now, if I start distributing that w, I see that I have 3w squared minus 13w. This is a quadratic. How do we solve quadratics? Yeah, factor or what formula? We do have to minus the 10 because we have to set it equal to 0 before either of those methods work, factoring or quadratic formula. So I have 0 equals 3w squared, minus 13w minus 10. There is no GCF. So I would try to factor this. The last term is negative, so that tells me I'm going to have different signs. 3w times w would give me 3w squared. 10 consists of factors of 5 and 2, or 10 and 1. If I make the 5 here and the 2 here, negative 15w plus 2w does equal negative 13w. Then we set each factor equal to 0 and solve, so we get w is equal to 5, or w is equal to negative 2/3. Now you do have to be careful with log equations because you can never take log of 0 or log of a negative. So let's take a look back up at the top. Are there any answers that we should throw away? Yes, negative 2/3, because right up there, that creates a log of a negative. And we can't have a log of a negative. So our only answer should be w equals 5. Okay, of those type that we reviewed, you can anticipate 3 to 5 questions over chapter 4 to show up on the final.
How many?
Oh, sorry, not of those specific type. We have a few more interest ones as well. There's 3 to 5 that will be from chapter 4. And in working with exponential equations, one of the highest applications is working with interest and investments. So let's see if we can remember how to work with these few. Number 10, an investment of $5,000 increased to $12,432 at an interest rate of 6.8% per year. If the interest was compounded continuously, find the time it took for the investment to grow to the given amount. Here's some good news. I will give you the equations for continuous compounded interest or the other one. So continuous, yeah, that's right. The amount in your account equals principal times E raised to the RT. Now, I obviously won't tell you what the letters stand for, so you will have to know how to apply the equation. So what does the investment represent? P, good. Our investment is our principal, so we're going to put 5,000 in for P. What does A represent? Total amount. So the amount in our account is 12,432. E is just a number. How do I express the interest rate in the equation? Decimal, good. So it'd be 0.068 because you have to move it 2 places to the left. So raised to 0.068 times, and what are we going to put for T? T, because that's what we're solving for. Find the time it took. So now this is an equation that we do need to know how to solve. What would be our first step? Good, divide by 5,000. You have to isolate the base before you can start using those logs. So we have 12,432 over 5,000. If that turns out to be a decimal, we want to try to keep it in fraction form because you never want to round within the context of a problem. But if
1,554
12, 3, right? 2.4864. Did I type it in wrong? 12,432.
No, that's right. And then the fraction is 1,543 over 600.
Okay, you're ahead of me. So this one did, it didn't go on forever and ever, so I could use the decimal equipment, or the decimal equivalent, not equipment. Or I could just leave the fraction. I could reduce the fraction as well. You do want to be careful though, if the decimal keeps going, like this one up on my second line of the calculator, I would not want to use that answer because that's been rounded. And we do have to be exact when we're working. So I have 2.4684. 2.4864, sorry, I can't. Equals E raised to the 0.068t. I'm messing up my numbers today. There we go. And now what can I do? ln, good. So, or you could just change it to log form. If you have just one base, you could just change it to log form, and that's another method you can go about using. If we continued with this as we have it though, when I bring the 0.068t in front, what is ln of E? 1. So essentially it goes away as well. And what's the last step I would do? Divide by 0.068.
Wait, why do you multiply by 2?
By what? Oh, it's 1. Natural log of E is 1. So then I'm going to take natural log of that answer, second negative, and I'm going to divide it by 0.068. Is that what I said? Thank you. Divide that answer by 0.068. And it should be 13.39 if we round to the nearest hundredth. So it says, find the time it took for the investment to grow approximately 13.39 years. All right, number 11, I'm going to give you the formula, and then I'm going to ask that you work through it with your partner. So it says you would like to have $20,000 for a new car in 7 years. How much should you invest now at a rate of 3% interest compounded monthly in order to have the desired amount in 7 years? So if it's continuous interest, it's PERT. If it's any other type of interest, it's equal
1 minus
1 plus.
R over N
Good.
raised to the NT.
Nice. We looked at how this value, 1 plus r over n raised to the n, if n goes to infinity, it actually came out to be e We looked at it in a different way, but this is the equation that you would have to use for monthly. Go ahead, turn with your partner, see if you can solve this problem.
All right.
Yes, ma'am.
20,000 is your A.
So you can plug a whole way. Yeah.
And then over,
0.03
over, yeah, 12, and then 12. Oh, I was like, what? I was like, wait, how did you get that? Okay, so basically, I would just take this as quantity and divide it by.
That is the number of times it's
Probably
compounded
not.
annually.
I'll just count it, so.
So we're just gonna get the crazy number.
0.93.
That's real.
You only do two.
Twelve times 7 is 84.
Yeah, I got like 16,000.
That's the way it is.
All right, guys, when you get your answer, it should be $16,215. And technically, you should say 94 cents, because if we say 93, we will not have that amount at the end of 7 years. We'll have just a penny short. On the final, I will not be that particular. You won't have an answer A like 0.93 and an answer B like 0.94. There will just be the answer closest to what you should have solved for. But it is kind of important to see that you do want to round up so you have that money at the end of the year. So it's $16,215.94. $16,215.94. And that is chapter 4, review. On to the most recent chapter that you've taken a test over. I know you took a quiz over chapter 8, but chapter 5 and 6 is the last test that you took. So hopefully this will feel easy as we go through it. Number 1, for each of the following, determine if the matrices can be multiplied. If they can, state the dimensions of the resulting matrix. You do not have to actually do the multiplication. So looking at letter A, the first thing that you're going to want to ask are, what are the dimensions of that first matrix? Raise your hand if you can tell me. What are the dimensions of this first one? Charlie. 5 by 5. Awesome. Raise your hand if you can tell me what are the dimensions of the second matrix. Lily? Yes, 5 by 1. Awesome. Because it has 5 rows and 1 column. Can someone tell me, can you multiply and why? Lainey?
Yeah, you can, because the two middle numbers.
Nice. The columns of the first match the rows of the second, so we can match. And can someone else raise their hand and tell me what would be the dimensions of the resulting matrix? Cayman.
5 by 1.
Awesome. 5 by 1. Awesome. All right, letter B. Letter B. Try that one on your own. Okay, can someone raise their hand and tell me, what did you get for can you multiply and why? Grant.
No, because the inside numbers are.
Nice. No, the inside numbers do not match. So the answer is just not applicable. You can't multiply them. All right, more work on matrices. Which of the following are not true? Circle all that are not true. Be sure to read the notation carefully. Letter A. Letter A, we have a 1 by 2 matrix. 1 by 2 multiplied by a 2 by 1. And the answer came out to be a 1 by 1 matrix. Most likely, would this one be true? Yes. Could I check it on my calculator?
Yeah.
Yes. Now, a few of you learned how to do it by hand. you could actually just multiply the row by the column. 3 times 2 is 6, plus 2 times 1 is 2. 6 plus 2 does give you 8, so it would work. But you could, on the calculator, good question. So if I'm checking this on the calculator, I would press alpha zoom to enter in a matrix. And I want to make sure that I enter in the first matrix has how many rows? 2 and how many columns? Is it a 2 by 1? Is it a 1 by 2?
Yeah.
Thank you. Sorry, I don't have it in front of me because my calculator takes up the whole screen. So 1 by 2, and then I'm going to go down and press OK. And I'll enter in those elements, which were 3 and 2. 3, 2. And I'm going to multiply it by, again, alpha zoom. And this one was a 2 by 1. So I'm going to go up, select 2 by 1, and go down and press OK. And what were the elements of this one? 2 and 1?
Yes.
Thank you. And I press enter, and it says the answer is 8. Correct. So we say that's correct. On to letter B. Letter B, you have a scalar, the number 2. What do you do with a scalar? Just distribute. So do we get 6, 12, 10, and 4? Yes, that one works. Letter E. If you're taking a 2 by 2 and adding a 2 by 2, do you get a 2 by 1? No, it has to be the same dimensions for addition and subtraction. So letter C, this is not correct. Letter D, you have the first matrix, we could call it A second matrix we could call B. Is that equivalent to B times A? No, matrix multiplication is not commutative. You could check this on your calculator, but you cannot reverse the order. So letter D, no, we cannot switch the order of the matrices.
So you don't even have to like check the.
It won't be correct. Yeah. On to number 3. Solve the system of equations using any correct method. How do we get rid of all those fractions? Yeah, multiply by the least common denominator, which would be 12 here. I'll put my result below. So this would be 4x minus 3y is equal to 24. Now, do you guys want to use substitution or elimination? Elimination. So I would multiply this bottom one by 2, which would produce 4 times 2 would give me an 8x. 3 times 2 would give me a negative 6y. And then 2 times 24 would give me a 48. When I add straight down, any number plus its opposite is 0, and I get 0 is equal to 58. What does that mean? No solution. It means if I graphed these 2 linear equations, or these 2 lines, I would see that they don't touch. They should be parallel lines. They would never intersect. Number 4, solve the system of non-linear equations. Do you guys want to use substitution or elimination? Substitute.
I have a question.
Yes,
So for that other one, you add them or? like,
you
how do
add straight down, always in the process of elimination, use addition.
Okay.
Some other countries even call it the addition method. Number 4, why don't you turn with your partner, because there's different ways that you could go about solving this. Why don't you guys try solving this one together?
I know, bye-bye. So which one do you want to do? Just one. So then you get negative 2x squared minus 2y squared equals negative 8. So then you have 1, sorry, I don't went this way, I got 12 out backwards. Just cancel that out, and then you get negative 5y squared. Divided by negative 5.
So x squared equals
So y squared equals 4. Square root
So the answer
Negative
goes down
y
and find
equals
y.
plus or
So what's
That's what I answered.
I got Y plus or minus two.
because you only have to take a portion.
So 0 to
X
0.
would be
Oh.
Oh, yeah.
0.
Oh, wait.
Crazy, crazy.
Why do we have to put it as like a like a coordinate plane thing?
Because if we, every system of equations can be graphed on the XY coordinate plane. And the answer is where the two curves cross. And so if I was to get these alone for Y and solve them on my calculator, I would find that the 2 point of intersections would be at 0, 2 and 0, -2.
Did you always want to write as coordinates?
Always write as coordinates. That's how the answer would be listed on the final.
Just like for everything or just for like?
For all systems of equations, or linear or not. Elijah,
So should we like on the test just type those into a calculator?
you could. You would have to get Y by itself and make sure to type in the plus and the minus. And then get this Y by itself and make sure to type in the plus and the minus. And then find the point of intersection. All right, on to words problems.
Oh, can I ask you a question?
Yes,
So say you had something like where you solved it and it was like 0 equals 0.
that means no solution. Or sorry, that means 0 = 0 is a true statement, which means that there are infinite solutions. So if there are infinite solutions, so let's say, let's
Would
just,
that be with any number?
Doesn't that mean
Like-
the same?
it means that they're the same line, and so you have to answer it as all X such that the Y values match that same line.
Okay.
What if you had like 58 equals 50? Same thing.
That's it's yep, it's a true statement. So it means that you have infinite solutions, and the way that we answer that is as an ordered pair. I would revisit your test or the book for this because that gives you additional practice over those types. Good, good questions. All right, number 8, Clarice wants to invest $100,000. Her financial planner advises her to invest in 3 types of accounts. One paying 3%, one paying 5.5%, and one paying 9% simple interest per year. Clarice wants to put twice as much in the lowest yielding, least risky account as in the highest yielding account. How much should she invest in each account to achieve a total annual return of $5,080? First thing that's good to do is define what we're finding. So I like to start at the end of the question. How much should she invest in each account? So I'm going to say X is the dollars to invest in the 3% account. Y would be the dollar to invest in the 5.5% account. And Z would be the dollars to invest in the 9% account. Then we can start setting up equations. How much total money does she have to invest? $100,000. So I could say X plus Y plus Z has to equal $100,000. Which one's the least risky? The 3%. Which one's the most risky? The 9%. So this is the most risk.
So that would be X equals 2Z.
So it says she wants to put twice as much in the lowest yielding. So I would start with the one that, yeah, that she's going to have more dollars in. So if she's going to put more dollars in X, then I'm going to say X equals how much more? She's putting twice as much in the high, or she's putting twice as much in X as she is in Z. So what did you say, Lily? I just want to check. X equals 2Z. Perfect.
And then the last
And
one.
it says, how much should she invest in each account to achieve a total annual return of $5,080? How are we going to set up that one?
0.03x,
0.03x, good, plus
0.055,
y, good, plus
0.09.
z equals, how much does she get back? 5,080, awesome. Now, rather than spending all the time to work through a system of 3 equations, do you guys remember that we could just use RREF on this. But we do have to line up our coefficients. This would be 1, 1, 1, 100,000. 1, 1, 1, 100,000. This one I would have to rearrange, so I'd have to subtract the 2z, so it'd be x plus 0y minus 2z equals 0. And so that would be 1, 0, negative 2, 0. And the last one would be 0.03, 0.055, 0.09, 5,080. Okay, do we remember how to access RREF?
Nope.
Oh, no. Let's review it. If you go to second matrix, do you remember where to go after that? So second x to the negative first, excuse me.
You go to math. and
You go to
then
math,
press the up button and
go
then-
up, good, to RREF, which is letter B. And then how do we enter in a matrix?
Out.
Alpha zoom. This matrix would be a what dimension? 3 by 4, awesome. And then I press OK. And I'm going to do 1, 1, oops, not 2. 1, 1, 1, 100,000. And then 1x, 0y, negative 2z for the next row. And the last one was 0.03. Man, I like working with a real calculator better. There we go. 0.03. 0.03. And then 0.055. And 0.09.
What's over there?
Wait, what?
How much money do you get back? 5,080, is that it?
I didn't get it.
5,000.
Yeah, 5,000.
Thank you.
Dang it.
56,000.
This is what your calculator should look like. So before I press enter, actually, I think I could still press enter and it will still show up on my calculator. You want to make sure you have that. Then you press enter. And the 1 represents the x. So x equals 56,000, y equals 16,000, z equals 28,000. So the amount that I'm going to invest in my 3% account is $56,000. In my 5.5% is $16,000, and in my 9% would be 28,000. Jack.
So on the SB one, we have to multiply any of the three variable equations, like by hand.
Nope. It's all multiple choice. So, and I taught you guys a faster way, so I'm not going to have you do it the longer way. But that's a good question. And make sure we have dollars. All right, we just reviewed how to solve that by hand. So number 5, why don't you turn with your partner and try this one together? Yeah.
Does all of our work have to be shown?
Yeah, it's a scan trap.
Okay, so
That should be. All right, let's do this. It should be. Currently, 5 solutions with certain as the first and
no, 15 times.
second.
No, wait, so I'm sorry, the third one is.
Oh, yeah.
50%, not 30. And then you would do 0.1x plus 0.3y plus 0.5. 0.1x plus 0.02y plus
Yeah.
0.
Wait.
Wait, what is this next one?
Yeah, it's just
6.1
So in our REF.
Yep.
Okay, wait, I'll do 6. Second.
Or no, not, no, this would be on second. Wait, are we sure AC equals 2y?
Yeah, because it said twice as much as the 50.
So it's supposed to use twice.
And then xy equals 0. It must be
So-
twice as much as 50 as x. So then it's gonna be the 50% solution of the c. Going to be
Two
c
Y.
times squared.
Yes, then you have to
Okay.
use
And
that.
then
Plus
Minus two Y.
negative
y 2y equals c.
and you get 0 x.
So then we transform that equation
0 y
to
minus
0x
Right.
plus
0x minus 2y plus
2y
16
minus c.
is what the last equation is. So then you put in
I got this.
1 and then
Right,
we have
Is already,
oh,
it's just the matrix thing.
0, 2,
like this,
1,
like the little row guy. That's alpha. Okay, so then did you get 17 1 and 42? Yes. 3 by 4 as well.
Also, what's 51?
Oh.
You got 1.
Okay.
Yay.
Or, yeah.
Oh, should we do the last one? Yeah.
Yeah.
Opposite.
Okay.
They punched it 3 by 4.
What are they? 2 by second? They're 2 by 2.
So
Second, read. 1.
Alpha.
So that's.
Okay, got it.
All right, ladies and gentlemen, your 3 equation setups should look like x plus y plus z equals 50, 0.10x plus 0.3y plus 0.5z equals 0.32 times 50, and z is equal to 2y. If you used RREF, your answer x, the amount that you should put, the amount of solution of 10% is 17 liters, 11 liters of the 30% solution, and 22 liters of the 50%.
And when you do it, you have all these sitting in the zero spot, so Y two.
Lastly, make sure you can do a matrix product,
Minus 2.
which we
And then Y to the-
did already check in the first example, so I believe you all know how to do it. I'm gonna go ahead and try this one by hand. The element in the first row, first column, should be -8 plus 9, which is 1. The element in the first row, second column, should be -2 plus 15, which would be 13. The element in the second row, first column, should be 32 plus 3, which is 35. And the element in the second row, second column, should be 8 plus 5, which is 13. Now, I didn't show you guys how to do it by hand, but you should be able to type this in on your calculator and determine the product, which is 1, 13, 35, 15.
How do you do it? You do that outside?
I mean, if you wanted to know how to do it by hand, this element is in the first row, first column. So I'd line up the first row with the first column, and I would multiply -2 times 4, which is -8, and add that to 3 times 3, which is 9, and so that gives me an answer of 1. If I wanted to know what's the element in the first row, second column, then I'd line up the first row with the second column, and I do -2 times 1, which is -2, plus 3 times 5, which is 15, and that would give me 13, and I keep going. But I taught you guys how to use your calculator, so you can do that also. All right, you have 35 minutes to finish up what you didn't complete of the first packet. So the first packet, I did have the answers for you guys, but you guys were finishing chapters 8 and 9. So whatever you didn't finish with your partner, you can go ahead and keep working on to complete. Other than that, your homework for the final is to just try the problems that are bolded that you feel you need more review on. Use your practice test to go back through. Your quiz for chapter 8 would be a good thing to revisit. And then you guys can just go ahead and use this time.